So now I want to do the second problem on page 11. This one was going to take a little bit more time than I wanted to put in on the last video. That's why I split this up. So this one shows the similar type of information, but it's only in a graph. So this shows Donovan Bailey's split times for his 100-meter record-breaking run in the Atlantic Olympics in 1996. So you've got distance in meters versus time in seconds, and it asks at what point did he experience his greatest average speed for a 10-meter interval. So if you look at the data points that are here, we are given his time every 10 meters, which allows us to figure the answer to this question out a little bit easier. But this also means that we actually have to look at every time interval. And since the material is not in a table format, we're going to have to look at it bit by bit. And it says here PSYW, which means please show your work. So I'm going to show you what I did for this. So for each time interval, I took a look at the shortest amount of time it took him to travel those 10 meters. So I went through, and I know this is not necessarily the easiest to see, but hopefully it will make sense as we go through it. So here, it took him 1.9 seconds to travel those 10 meters. And then in this next time interval, it took him 1.2 seconds, and I got that by taking 3.1 and subtracting 1.9. So in this time interval, it was 1.2 seconds. In the next time interval, it was 1 second, and I got that by taking 4.1 and subtracting it from 3.1. In the next time interval, it was 0.8 seconds, which was gotten by 4.9 minus 4.1. The next interval, 5.6 minus 4.9, which is 0.7. The next time interval, 6.5 minus 5.6, which is 0.9. Next time interval, 7.4 minus 6.5, which is also 0.9. Next time interval, 8.2 minus 7.4, which is 0.8. Next time interval, 9.0 minus 8.2, which is 0.8. And the last time interval, 9.84 minus 9.0, and that's 0.84 seconds. So if I am trying to find the shortest amount of time for this, I need to look at all these numbers and decide which one is the smallest. So in this case, it is 0.7 seconds, which is why I circled it here in red. So pause the video, copy down what you need, make certain you understand what I did in order to arrive at the fact that this shortest time interval was 0.7 seconds. So we wanted to figure out what time interval did he travel the farthest in the shortest amount of time. And so the time intervals weren't equal, but the distance were all 10 meters. So he traveled 10 meters in 0.7 seconds, and this is 14.3 meters per second. Now, a couple of comments about writing units and things like that with this here. So things you've got to pay attention to is meters is abbreviated M, and miles is abbreviated MI. And you really need to be careful when you're writing these that the I is very clear, because sometimes if we're a little careless in our writing of the letter M, you can't tell the difference between your M and your MI. And if you're writing miles when it should be meters, the units aren't right. And that actually has a fairly big difference because a meter stick is fairly short and a mile is fairly long. So they have very significantly different meanings. So you want to be very careful as you're writing your units and making it clear. A lot of people actually write out the word miles instead of doing MI, and it's always fine to write out the entire unit instead of abbreviating it. The second comment I want to make is that seconds is typically abbreviated S, and I learned the hard way in school that my S's, when I was sloppy and rushing, they looked a lot like a 5. So I started writing SEC or seconds instead, because otherwise I started making mistakes, not only with my numbers, but with my units. And so just a word of caution to you to try to be careful about how you're writing those units. So the other part for this question is we wanted to find what his average speed in meters per second for the overall race was. So in order to do that, we're going to look at his total time and his total distance. So his total distance, if we go back and look at the chart here, he went 100 meters, and he did that in 9.84 seconds, which is extremely fast. So in that, we took 100 meters divided by 9.84 seconds, and we've got our answer of 10.2 meters per second. And for this, we ended up just wanting the speed, so there's no displacement, no vector, no direction needed. So that is the answer to the second problem on this page. So there is really no follow-up work to do with this. Once you feel like you understand these problems, that's good. You can go ahead and move on to the next video.